Hey folks, welcome to the next class in the series of Basics to Advanced, the topic time and work. Already done one class on this, on working with different efficiencies, and today we're going to talk about pipes and cisterns and man days. That's going to be the two main ideas. So quickly looking at the concept that what are pipes and cisterns, what are man days. We understand pipes. When we talk about pipes and cisterns, cisterns is a word that is synonymous with a tank. It's going to be the same as working with different efficiencies. And then when we talk about man days, it's going to be a group of people working with it. So let's quickly attack these two concepts and then solve a couple of questions so that we build some momentum over this topic. So to begin with, when we talk about pipes and cisterns, now what is the idea behind pipes and cisterns? Simple. There are pipes that are filling a tank. So we visualize it. In this topic, the total work will become the capacity of the tank. Back then we spoke about units when we did LCM method. We talked about the total work being some units. Here, every time I say total work, I'm going to assume it to be the capacity of the tank. So nothing fancy here. So quickly revising that idea, if A can fill a tank in 12 minutes and B can fill the same tank in 60 minutes, if both tanks are open together, both pipes are open together, when will the tank get filled? So nothing fancy here. I'm going to say the total capacity is equal to LCM of 12 and 60 happens to be 60. So I'm going to call it 60 liters. So 60 liters can be filled in 12 minutes by A. So from here we can say 5 liters per minute. 60 liters can be filled by B in 60 minutes. That will be 1 liter per minute. So if both pipes are kept open, that will become 6 liters per minute. So total time is equal to 60 liters by 6 liters per minute. That will be 10 minutes. A simple idea to work with, nothing fancy here. But the one added layer that we have in pipes and cisterns will be something called a drain pipe. Something that we did not see in the previous case, that's called a drain pipe. What is a drain pipe? Now all this while we have been looking at positive work being done. But when I talk about a tank, pipes and tanks, I understand that there are pipes that will fill a tank. There are pipes that can drain a tank. That's removing the work. So all we do is we assume this to be negative work. How do you look at this question? Now, same question, let's say there are two pipes A and B. A is a fill pipe that can fill in 12 minutes. B, I'm going to say that's a drain pipe now, that can fill it in, that can drain a full tank in 60 minutes. How do you look at this question? Same idea. Total capacity is 60 liters. If I write it that way, 12 minutes will become 5 liters per minute. This will become 1 liter per minute. But since it's a drain pipe, it's removing from it. It's removing the quantity from it. It's taking out 1 liter per minute every time. So for every minute, it is removing a liter. So to denote that, you simply add a negative sign. So this will become, if I say A plus B, again plus B means they are working together. This plus over here, I don't try to say they are getting added. I'm saying they both work together. In that case, 5 minus 1 will become 4 liters per minute. So that will be 60 divided by 4. That is 15 minutes. And that will be our answer. It's the only task. It's the only thing that we need to understand here. So drain pipes do negative work. The moment we get that, we are through. And you also have to understand that the filling time of a pipe, the fill time is always less than the drain time. As a result, the efficiency of filling, the filling efficiency is always greater than the draining efficiency. What do I mean by that? Now if a tank takes 60 minutes to get filled and it takes 12 minutes to get drained. If both pipes are kept open, the tank will never get filled. Why? Because draining efficiency would be more. So I always look at the point that the filling time should always be lesser than drain time, and the draining efficiency should always be less than the filling efficiency. The moment we get this, we are through. So nothing fancy here. A couple of questions can be tricky based on how the questions are framed, but otherwise the concepts stay the same. Now if I look at man days here, now what about man days? Now man days is an idea that we can probably use it in our day-to-day life. A lot of people, when they assign tasks as projects as a group, they talk about it. Now what are man days? In short, I say number of men into number of days. This man days, which is taken to be the total work. What do we mean here? Now, when I say 10 men can work for 10 days, in my head, I think about it as 100 man days. What do I mean by 100 man days? I tell that if 10 men can finish it in 10 days, we automatically can understand that if 20 men work on it, it will take 5 days. What is the assumption that we have here? Anyone working in that group works with equal efficiency. If one man can do 1 unit a day, 10 men can do 10 units a day, and in 10 days they do 100 units. So number of men into number of days is your total work. If there are 20 men can do 20 units in 1 day. So to finish 100 units, they would take 5 days. So 10 men can do it in 10 days. 20 men can do it in 5 days, or 100 men can do it in 1 day, or 1 man in 100 days. So the idea is same. Number of men into number of days will always be your total work. In all these cases, we notice that the total work we accounted to be 100. Nothing fancy, because we know that number of men is inversely proportional to the number of days taken. What do we mean here? More the men, lesser the days, or lesser the men, more the days. We can notice it. As I keep increasing, the days gets decreasing. I decrease, it increases, right? The same we can say it for hours. If I have more people working, I can make them work for lesser hours, or I say that number of men is inversely proportional to number of hours worked. But what about work? What happens to the work when I have more people? If I have more people, we can do more work, right? Less people, lesser work. Of course, if I have more people, the same amount of work can take lesser days. But if I have more the number of people and my time constant, I can do more work. If 10 people in 1 day can do 10 units, 20 people in 1 day can do 20 units. I have more the people to work, I can finish more work. So we say number of men is directly proportional to the number of work. Now this is true for any given case. So unit per work, amount of work done by one person, we always account it to be N into D into H by W. The total work done by the total amount of work done, right? This will be average work done by one person. That's what we are writing. This will be equal for any given case. If there is another case, if this is for 10 men working group, if there is another group where 20 men are working, it will be the same. But how do I equate it? I say N1 D1 H1 by W1 is equal to N2 D2 H2 by. This is the formula that we use to solve man days. This is for case 1, this is for case 2. We plug in that concept, everything falls in place. You have to understand the number of people working in a group and the number of people working in the other group, they all work with equal efficiency by assumption, by default. Unless or until the question has mixed type of people like men, women, men, children, that's a separate case which will attack. But to begin with, the chain rule that we follow is N1 D1 H1 by W1 is equal to N2 D2 H2 by W2. Plug in this formula anywhere you look at number of people working in different cases, will always get the answer. So we'll just plug in these logics, solve a couple of questions, and then we'll understand how to solve them. So we'll do the first one here. First question says a pipe fills a tank in 8 hours and another pipe fills it in 12 hours. A leakage pipe can empty the full tank in 24 hours. If all three pipes are open together, how long will the tank take to fill? Simple idea. Let's say there is pipe 1 that takes 8 hours, pipe 2 that takes 12 hours, and then there's pipe 3 which is a drain pipe which takes 24 hours. All three pipes are kept open, so I'm going to take the LCM here. So the total capacity I can take it to be 8, 12 and 24. The LCM will be 24 liters. So this is 8. This will give me to be 3 liters per hour. This will be 2 liters per hour. This will be 1 liter per hour. But this is a drain pipe, mind you. So I'm going to put a minus. So what is the amount done per hour? P1 plus P2 plus P3 is equal to 3 plus 2 is 5. 5 minus 1 is 4. That will give me 4 liters per hour. So if all three of them work together, that will be 24 by 4. That will be 6 hours taken to fill the tank. Nice question. All you have to just do is find the total work, find efficiency, add them, and then divide the total capacity. We'll get the time. Simple trick, nothing to worry about here, right? Let's have a look at the second question. I'll give you a second to look at it. Right. 3 pipes can fill a tank in 10, 15 and 20 hours respectively. All the pipes are open together, but the third pipe is closed after 2 hours. How much total time will be required to fill the tank? So we are looking at 3 pipes. Let me call it A, B, C. 10 hours, 15 hours and then 20 hours. Total capacity will be 10, 15 and 20 will give us 60 as the LCM. So 60 liters. This will be 6 liters per hour, 4 liters per hour, 3 liters per hour. So all pipes are open together, but the third pipe is closed after 2 hours. The third pipe is C for us. So for the first 2 hours it is A plus B plus C, but after that it is going to be only A and B. So this will be 2 hours. This we need to find out. Let's find it. If I put all 3 pipes together, that will give me 6 plus 4 plus 3. For 1 hour, 6 liters, 4 liters and 3 liters per hour, but they are functional for 2 hours together. That will be into 2. So this will give us 13 into 2, 26 liters filled. So out of 60 liters, 26 liters is done. That means I still have 34 liters to fill. But the question is, how much total time will be required to fill the tank? Now this 34 liters has to be filled by A and B, who is capable of giving me 10 liters. So some X amount of liters of 6 plus 4 will give us 34 liters. 10x is equal to 34. X is equal to 3.4 hours. So we already have worked for 2 hours. Now we have worked for 3.4 hours. That will be a total of 5.4 hours. Or if we have to do it as proper time, this will be 5 hours and 24 minutes. How 24 minutes? 4/10 of an hour into 60 minutes is 24 minutes. So 5 hours and 24 minutes will be our answer. Same idea what we did in the previous class. It's just that we also have to think about drain pipes. This question fortunately does not have any drain pipes, so it's a simple addition process through the time, right? I'll give you a second to look at the question and let's do this. 12 men can complete a work in 20 days. After 5 days, 4 men leave the work. And how many more days will the remaining men complete the work? So 12 men can finish a work in 20 days. So that's the total work I have. So the total work will be 12 into 20. That will be 240 units to be completed. Call the total work to be 240 units. So they start the work together. After 5 days, 4 men leave the work, which means for the first 5 days, we had 12 men. After that 5 days, 4 men leave the work, which means for the remaining time, we had only 8 men working. That's enough. So 12 men working for 5 days, they would have finished 12 into 5, that will be 60 units. How? We have taken to each one to do 1 unit a day. 12 men in 1 day would finish 12 units, into 20 is 240 units. But they are working only for 5 days, which means they can do only 60 units. So in this case, 60 units done. But we still have 180 units to be completed. Out of 240 units, still need to get 180 units, which we'll have to find. So in that case, this 180 units will be completed by 8 men working for X days. Let me remove this U. We don't want to have a variable while solving. This 180 is completed by 8 men working for X days. So what will be X? 180 by 8, that will give us 45 by 2, that will be 22.5 days. So that means 5 days work is done and then 22.5 days is done. That's a total of 27.5 days. But the question is how many more days will be required to complete the remaining work. In that case, this will be 22.5 only, because they are asking the time to complete only the remaining work, which means 22.5. Nice and simple. We'll do one more question. A contractor hires 18 workers to complete a work in 30 days. After 15 days, he realizes only 40% of the work is completed. How many extra workers are needed to finish the work on time? Same idea. So I am going to take N1. N1 is equal to 18. I'm going to say D1 after 15 days. So the total work is for 30 days is what it is planned. But these 18 people have worked for 15 days now. So D1 will be 15. And then W1, 40% of the work, 40% of some units has been completed. So I'm simply going to say 40. And the other case, I'll say 60% of the work to be completed. We can cancel it off then. Now here, N2, I'm going to call it 18 plus X. Why 18 plus X? Some more people have to join them to finish the work. So that's needed. D1, D2 will be 15 days again, because out of 30 days, 15 days are done. That means we still have 15 days left. W2 will become 60% of the tasks. I'm simply going to equate them. So that will become 18 into 15 by 40 is equal to 18 plus X into 15 by 60. So let's simplify them. This and this gets cancelled. This will be 2, this will be 3. 15 and 15 can be cancelled straight away. I can bring this at 2 and this will become 9. So we can write this as 18 plus X is equal to, this goes over there, becomes 27. X is equal to 9. So how many extra workers are needed to finish the work on time? We need 9 more people to finish the remaining 60% of the work in the remaining 15 days. And X will be 9. That's our answer. So these are cases where all the people in a group work with equal efficiencies. Now, what if there are people, the same group has different type of people with different efficiencies? How do the question framing come? How to solve them? We'll see that in the next video. But in case, if you have understood this entire part, solve this question, get your answers and drop them in the comment box. And then if you haven't joined the Telegram channels yet, scan the QR codes that will take you to the Telegram channel, where we'll be sharing exclusive content regarding our preparations. All the best.